Okay, we're doing angles in standard position. For this video, you've missed the little beginning part because I forgot to record, but now haven't missed too much. We're getting into standard position angles. So here we're given a particular reference angle and we're asked to find a standard position angle in each of the four quadrants. Complete the table stating the standard position angle, and that's it. You can do a little diagram if that helps. So here you might do, okay, there's my XY, just a sketch. 30 degrees is there. That's already in the first quadrant, so any angle in the first quadrant, the reference angle is the standard position angle. So here, I can fill that in right away because it's already an angle in the first quadrant, okay, less than 90. Next one, if I have a reference angle of 30, so I've got to start there, and I've got to have a terminal arm in the second quadrant, then that means this angle in here has to be 30 degrees. Okay, my standard position angle is that one. So in that case, it's 180 minus 30, which is 150 degrees. In the third quadrant, if I draw my terminal arm, it has to form a reference angle with that initial arm, the positive, of 30 degrees, so about like that. And so from here to here, that's, oh, sorry, that's quadrant 4. Let me move that over. Okay. Okay, this is longer to move it. Oh my gosh. They're getting someone to come in to look at the smart board, but I don't know when. Okay, I'll just leave that, let it do its thing. Okay, so let's do this again. Quadrant 3 would be here, and so this angle is 30. So from there all the way to that terminal arm will be 180 plus 30, which is 210. And then this one, if I fix that up, there we go. So that one, this is your 30 degrees, so that's going to be 360 minus 30 is 330 degrees. Okay, so same process. For quadrant 2 here, it's going to be a little higher up, but you're still going to go 180 minus 72. So that's going to be, what, 108. This one in the third quadrant, it'll be 180 plus 72. Because that's not going to get you over into the fourth quadrant. That's still in. So that's what, 252? Okay, and then 360 minus 72. Okay, that's going to be what, 288. And so in general, what were we doing each time there? Here, the standard position angle is the same as the reference angle if it's in the first quadrant. In this second quadrant, it's 180 minus the reference angle. In the third quadrant, it's 180 plus the reference angle. And in the fourth quadrant, it's 360 minus the reference angle. Okay, so that's a summary of reference angle, standard position. What happens if it lies on the quadrants where it divides the quadrants together on the axes? So give all the angles for theta between negative 360 and positive 360 that have a reference angle of 0. So we call these quadrantal angles. Really, we don't end up using them that much in terms of calling it a reference angle. All right, so if you look at your XY axis, so if you think about having a reference angle of 0, there's your initial arm, and so your terminal arm is going to be right on top of it, okay? So what are your angles? Would be 0. Then complete rotation there would be 360, or backwards would be negative 360. What about if my terminal arm was on this negative x-axis? Again, the reference angle, there's 0 between that and the x-axis, so that would be 180, or going the other way, negative 180. Okay. 90 degrees, starting there, going there, so 90, and then obviously complete rotation after that. So 360 plus 90 would be beyond this interval, so we wouldn't include it, okay? Going this way would be negative 270. What about if we had the terminal arm going in the negative y? Then that would be negative 90, or from here, positive 270. Okay, so plus or minus 90, plus or minus 270. Okay, so now, again, doing a little sketch of these ones. So 100 degrees. So initial arm, 100 degrees would be maybe about there. Label it with an arrow going in the positive direction. 460. Complete rotation is 360. Whoa, we're going 100 more than that. Same terminal arm. Okay, it looks different because I've actually labeled how I'm rotating through. Then here, positive. Now I'm going negative 260. So there's 180, 260. Oh, that's interesting. That angle over here that we haven't included is 100 degrees, right? So this is negative 260. So it has the same terminal arm, but the arrow's going the other way. And then positive 820. So what's that? That's 360, 720, 820. Again, same terminal arm. Just more of a rotation. So all of these are coterminal, meaning that their terminal arms are in the same position on the coordinate plane, but the amount of rotation is different. The reference angles of coterminal angles are the same. Okay? So here, the initial was 100. That reference angle then would be 80. So this here would be 80. This would be 80. This would be 80. This would be 80, even though they're different sized angles. When an angle is in degrees, to find a coterminal angle, just add or subtract increments of a complete rotation, 360 degrees. Okay. So these are sort of the easy questions on the test, finding coterminal angles, finding reference angles, that kind of thing. Write 2 positive and 2 negative coterminal angles for each of the following. So just in the chart we've separated, put the positive ones in the first column, negative in the second. So positive, so when you're given this angle, a coterminal angle to it isn't itself. So just be aware of that. You can't say write out 123 plus another one. That's not going to count. So just realize that. Don't take the easy route out if you think that, yes, it has the same terminal arm, but it is that same angle. So we want to add 360. So that's going to be what? 360, that's 483. Did I not add correctly? 123, 360. Yeah, 483. And then add another 360. 843. Okay, if you want to be annoying, a little bit annoying, you could add whatever 99 times 360 is, and that's still coterminal. You could add 80 rotations and still be coterminal. I like you to keep it smaller so I don't have to test all those, but technically it would be correct. I always have one student that will do that. Then negative ones, so you can go 123 minus 360, which really, you do it the other way around, that's going to be what? Negative 237. And then subtract another 360. So that's going to be what? Negative 597. I made a mistake. Let me know. You also have your calculator, right? So you have that to check. Starting with a negative 1. So if we add 360 to this, we're still going to have a negative, right? So I'm going to put that over here. Add 360 again. That'll be a positive. Add 360 again. Get another positive. And then we can subtract 360 from this one. And so that's negative 400. Again, you can do multiples of 360, but I try to keep it close. Okay. As we go on in this unit, you're going to be asked to solve trig equations, and there's going to be multiple solutions, infinite number of solutions, but they're all going to be rotation of each other, so coterminal. So you'll have something like this. Solve a trig equation where beta is between negative 720 and positive 720. So you have to make sure you list all of the values. So here, all angles beta coterminal with 200. We're not going to list 200 because it's asking for coterminal, but then add 360. Okay, so that would be 560. If we add 360 again, it'll be too big. Okay, so add, or you can go 200 minus 360. So that's going to be what? Negative 160. And then subtract 360 again from that. That will be what? 360, 420, negative 520. Subtract 360 again, won't fit into that interval. So there's 3 values there. Okay. That fall into this interval of values. Okay. Now it says write an expression for all angles coterminal with beta. So how do you do that? So again, we'll be doing this a lot later in the unit. So beta equals 200, and we're going plus or minus 360. Okay, that would be just plus or minus 360 once. We're could do multiples, right? All, it goes to infinity. So 360n, where n, in this case, because I've done plus or minus, then I've incorporated the negatives. So where n is an element of the natural numbers, so for you guys, that's z plus, okay, positive integers. If you didn't have the plus or minus, then you go 200 plus 360 degrees times n. And actually, in that case, we might say integers, which is z for you guys. I guess no, I should have just done a z there. Saying that, we'll do that more when we get to solving, because integers include 0. So if I include 0 in there, I'm actually including the 200, which technically 200 is the angle, not the coterminal to it. So I'm just going to put that in brackets. That's just going to help us when we get later on, as I said, when we're solving. Really, for right now, you would show it like this. Okay. Okay. Now we're getting into radians. So this is the new stuff, and you will remember that when we clear your calculator and you're doing trig, you always have to put it back into degree mode. Its default setting is radians, and that's what we're learning now. Okay, so for us in this unit, you might actually have to go back and forth. So you have to know where that mode key to change, or the wherever it is in your calculator. For TIs, it's mode. You have to go in and change it, perhaps to degrees, perhaps not. Okay. So just as distances and other quantities can be measured in various types of units, angles can also be measured in different units. Unit most familiar up until this point is degrees. Another unit is radians. Okay, just like you can measure something in inches and centimeters. The thing that you're measuring does not change. It's just a different unit of measure. So the angles aren't changing. You're just measuring sometimes in degrees and sometimes in radians. So we know kind of approximately what 1 degree looks like. You've seen a protractor before. It's just a little angle on your protractor. But what does 1 radian look like? So got to get to the definition. So let's remember some concepts about circles. Back to math 9. So arc length is the distance between 2 points measured along the circumference of a circle. So there's 2 points. That distance there, if you know the distance, is called the arc length. The length along the arc. A minor arc, so that would be an example of a minor arc, has a length that is less than half the circumference. Okay, so if we go through the center here, draw the diameter, right? Obviously that's less than half. A major arc would be maybe, we could go, say, from here all the way around to here. That would be a major arc. It has a length that is more than half the circumference. And the central angle is at where the vertex is at 0, 0, or sorry, at the center. So here, for that minor arc, this is the central angle. Okay, it's at the center of the circle. Central, center and central kind of makes sense. Okay. All right, so getting to the definition of a radian. So 1 radian is the measure of the central angle subtended. So the word subtended, back to math 9, means where those arms form an angle. So they end, so here subtended, oops, those two are subtended by that arc here. It's the math word for forming that angle. And there's your arc. So 1 radian is the measure of the central angle subtended in a circle by an arc equal in length to the radius. So this distance here, if we measured it, and if we say put a piece of string on it and then curve that string around on the circle, that would have the same measurement of this. Okay, that gives you 1 radian. Okay, so that's approximately. I've just drawn it. I've eyeballed it, right? That this radius here is about the same as this. Okay. Then, using the diagram, state approximately how many radians it would take to complete a full rotation. So this is a very similar circle. Okay, so again, if I kind of draw that out, about like that, just keep drawing. Approximately, that one I'm a little short on, I think, where that arc here is about the same as the radius. That's about the same. That's about the same. That's about the same. About the same. About the same. This one's a little different. Okay, so state approximately how many radians it would take to complete a full rotation. Well, that's 1 radian, 2, 3, 4, 5, 6, and a bit, right? So about 6, a little bit more, and a bit, which is good for an estimate, but we want to be precise, obviously. So, in order to find out exactly how many radians are in a full rotation, we need to find the arc length of a full circle. Okay, well, a complete rotation of a full circle, that's finding the circumference of the circle, right? So circumference, if you remember the formula, which I hope you do, is 2 pi r, or pi times diameter. Okay, so that's the arc length of a complete rotation. Okay, remember that to get the radian measures, so measure in radians, this, angle in radians, let's say, equals the arc length, and we're going to do more of this tomorrow, or Tuesday, I guess. Okay, and so if the arc length in a complete circle is 2 pi r, and our radius is r, what does that simplify? 2 pi. So for a complete rotation in radians is 2 pi. In degrees, it's 360. The circle is no different. Okay, so that's how it's developed, but this is the measure of a complete rotation. So 2 pi radians is the measure of a complete rotation. So therefore, 2 pi radians equals 360 degrees. Which is actually on the next part there. Radian measure is one of a nicer measurements in that you actually don't have to write the units. So you know how you probably got dinged some marks in Math 10 and 20, you forgot the degree symbol, you forgot centimeters, you forgot inches. Now if you forget for radians, you're actually okay. It's kind of like the default setting. You see an angle measure and there's no degree symbol on it, you have to assume it's radians. So it's great when you're working in radians, but if you're working in degrees, and say you have something that's 60 degrees and you want to find the cosine of it, okay, that's how you would show that. If you gave me this, then I would have to assume that you're talking about radians, which would give you a different answer. 60 radians is far different from 60 degrees, okay, because 2 pi radians, think about it. That value is 6 point whatever, 6.28 or 6.3 rounded. And so this is 60 as opposed to 6.3. So a very different angle if this was in radians. Okay. So we already put that down there. 360 degrees is the same as 2 pi radians. And the thing with radians, we're going to be using a lot of the angles as exact values. So not decimal forms, not really using our calculator a whole lot, using our brain. So you have to be pretty good with fractions. Hopefully you are. Okay. Fractions really with denominators 2, 3, 4, and 6. Maybe 12 sometimes. Other than that, we're not getting into any other crazy denominators. So let's look at more angles in radian measure by breaking the circle into smaller sections. So taking a look, we're looking at degrees here, okay, first, and then in radians. Convert this. Okay, so that angle, which is half a rotation in degrees, is 180. Okay, it's half of 360 degrees, right? In radians, remember 360 degrees is 2 pi. So if we take half of 2 pi, it's nice, it's just pi, which I don't need a calculator for that, 3.14. Okay. Next one, that is just 90 degrees. So we've taken the entire circle, 360, and divided it into 4, 90 degrees for that angle. So we've taken 2 pi and divided it into 4 parts, which reduces to pi over 2. Okay, so to 2 decimal places, pi divided by 2 is 1.57. This one here, you can see the circle is divided into 6 parts. We want just the first part there. So 360 divided by 6 is 60 degrees. 2 pi divided by 6 reduces to pi over 3. Okay, so pi divided by 3 in your calculator, 1.05. So you can kind of see in radians, the decimal form for an angle in the first quadrant is going to be less than 1.57. In the second quadrant, it's going to be between 1.57 and 3.14. Okay, next one, what's it divided into? 8 parts. So 360 divided by 8 is 45. Or you can think about, okay, that was 180 divided into 4 parts is 45, however you want to think about it. But here, 2 pi divided into 4 parts reduces to pi over 4. Calculator, pi divided by 4, 0.79. So again, it's less than 1.57 because it's still in quadrant 1. And then here, this one, 1, 2, 3, 4, 5, 6. So that's divided into 12 parts. So 360 divided by 12 is 30 degrees. So 2 pi divided by 12 is pi over 6. Okay. If you remember back to Math 20, we talked about special angles. We did some special triangles and the ratios of their sides. They were all 90-degree triangles, and these were the angles in them. Either it was a 30, 60, 90 triangle or a 45, 45, 90 triangle, right? This was all in a right triangle. Okay, So any multiple of those are also considered special angles. So if we have a reference angle of 45, so it's in, say, this quadrant here, so this angle that goes in quadrant 2 with a reference angle of 45, which would be what, 225, that's a special angle now. So if it has a reference angle that's 60, 45, or 30, that standard position angle is also a special angle. Okay. So they are all multiples. So they have all involve these three numbers. But remember, 60 is just 2 times 30. So they're multiples of 30 degrees or 45 degrees. Any multiple of 45. In radians, 30 degrees is pi over 6. And in radians, 45 is pi over 4. If you've ever heard of students talking about, well, I guess we talked a little bit about the unit circle last year, right? But that's a big part of this, knowing trig ratios of these special angles. And so we'll start talking about the unit circle and having the knowledge of those special trig ratios is super important. So do a demo regarding angles of rotation and write the exact values at the end of the terminal arm. So let's just take a look here. So if I go, I don't want to do, oops. Okay. So if I look at this one here, notice how it's divided into 12 pieces. So 360 divided by 12, that was the last entry in our chart, was 30 degrees, okay? So on your circle, we're going to label the first one here as 30. So you can see how it's divided this first quadrant into 30 degrees. So I'm going to write it here and then go back to your notes. So this would be 30. Oops. Well, the next one, these are all 30 degrees between. So this here to the next one would be 60. We're just going to label it at the end of the arrow, just because it's hard to label it around all in the center. It'll get very confusing. Add 30 to that, then this would be 90 degrees, which makes sense. Add 30 to that, this would be 120, 150, 180, and you just keep going around the circle. So you can add these or label these. So this is 0 and 360. Okay. All right, so let's take a look for those. Where are the lines that split this first quadrant into 3 parts? And we're going to do it in degrees and then radians. So here I'll do degrees in blue. Okay, and remember in our chart here, so that was 30 degrees, which was the same as pi over 6. Here's where the fractions, some students don't like fractions. So what's pi over 6 plus pi over 6? It's 2 pi over 6, which is pi over 3. Okay. What's pi over 6 plus pi over 6 plus pi over 6? Well, that's 3 pi over 6, which is pi over 2. All right, so that's 3 pi over 6 plus another pi over 6 is 4 pi over 6, which is 2 pi over 3. Okay, so you kind of have to remember your fractions. Now, saying that, you can always use your calculator, fudge your way through if you leave out the pi. So if you weren't sure what pi over 3 plus, I don't know, plus 2 pi over 3 was, or something like that, you go 1/3 plus 2/3. If you know it's a whole number, but and then put the pi in. Okay, so then adding another one, or thinking about this half rotation is pi. If we subtract pi over 6, that's going to be your reference angle. Think about it as a reflection in the y-axis. This is reflected to this. So those two reference angles are the same. And so 2 pi minus pi over 6 is 5 pi over 6. So sometimes you might use your transformation knowledge to help you out. Okay, and then this is pi. We already know that. And then pi plus pi over 6. Well, that's 6 pi over 6 plus 1 pi over 6 is 7 pi over 6. We rarely ever use mixed fractions, always improper fractions. 8 pi over 6 would be 4 pi over 3. 9 pi over 6 is 3 pi over 2. 10 pi over 6 is 5 pi over 3. 11 pi over 6. And 12 pi over 6 gets you back here, which is 2 pi. So that's 0 or 2 pi. Okay, so really, we've done most of them. The ones that we haven't done are these ones that divide each quadrant in half. So if I look at here, this one, I've divided in 8 parts. So now this is 0. This is 2 pi divided by 8, which is pi over 4. Plus pi over 4 is 2 pi over 4, which is pi over 2. Plus pi over 4 is 3 pi over 4. 4 pi over 4, which is pi. 5 pi over 4. 6 pi over 4, which is 3 pi over 2. 7 pi over 4. So we're just adding fractions. Okay, we've already labeled these ones on our unit circle, so all that we're missing are those diagonals. And again, think about transformations. That's pi over 4 to there, so that reference angle is pi over 4, right? So that's going to be pi minus pi over 4. This is a reflection in the y-axis. Okay, so back. Do this in red. So this is 45 degrees, 90, 135 degrees, 180, 225, 270, 315, back to 0. Okay, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4. Spend some time this weekend looking at this and the angles, figuring out, or you can memorize it, but really you just need to know this quadrant, first quadrant, and think about reference angles and reflections. Okay. All right. Come on. Now we found a few too many. There we are. Okay, so converting, you can always use a conversion just like you convert anything. But again, we're trying to get not to always have to write it out as a calculation. So let's just think about it. Most common conversion, 180 degrees that's half a circle, so that's pi radians. So 360 in radians, remember, is 2 pi. 180 is pi. Think about how these compare. If I divide that by 2 to get 90, this will be pi over 2. If I divide 180 by 3 to get 60, this is pi over 3. 180 by 4 to get 45, that's pi over 4. 180 by 6 is going to be pi over 6. And 180 by pi. Right? So, sorry, 180. So we divided by 180 to get 1. So this is going to be pi over 180. Okay. As I mentioned, these are the denominators that you're going to be working with the most. So you're not going weird numbers if you're doing it by hand sort of thing without calculator conversions. Some of them aren't exact angles. These were all exact. It says, how can we express any angle in radians? Well, think about a conversion, just like you do unit analysis in science. We want to go from degrees to radians. Then I need to have degrees in the denominator and radians in the numerator. Well, what's that relationship? 180 degrees is equal to pi radians. So now pi doesn't divide out, the zeros divide out, so I get 13 pi over 18. You can enter it in your calculator in this case, only if you're asked, otherwise we always leave it exact. Nearest hundredth would be 2.27. And short form for radians is RAD, rad. Not radicals, radians. Back when I was young, you'd say that as like, that was cool, that was rad. This is pretty cool. In the math world, it is. Next one, pi radians over 180 degrees. So what divides out there? 312 divided by 4. So 78 pi over 45. Does anything else go in? 3 goes into that. So 78 divided by 3 is 26 over 15. And then decimal form. Okay. Always have an idea. Like, think about it. 312 degrees. That's less than a complete rotation. In radians, 2 pi is a complete rotation, which is 2 times 3.14-ish, right? So 6.28. Make sure, is that less than 6.28, right? So do a sort of a mental math, does it make sense calculation. Okay. Then going from radians to degrees. A lot of times, probably at the beginning of this unit next week, I expect that many of you will go, if I give you a question with radians, you're going to convert it to degrees and then figure it out, because degrees is what you feel most comfortable with. But as you, hopefully you'll get more comfortable so that you don't have to do that conversion to then find a trig ratio. You want to be able to visualize it on the unit circle where it is, not without having to think, oh, what is that in degrees? And then on the unit circle. So if you think about these fractions, it ends up helping you out a little bit. So here, radians obviously in 2 pi is 360. So if we divide that by 2, we divide the degrees by 2. Divide by 2 again. This is really the same chart that we just did, except switched. This by 3, this by 4, this by 6, this by 180, degree symbols are getting a little crazy. So if they're not nice, so say I give you pi over 10, as I mentioned, we don't really use a lot of angles that have denominators different from multiples of 2, 3, 4, and 6. So this has 10. That's in radians, so that means we wanted to get it in degrees in our answer. So that means this needs to be degrees, and this needs to be radians, if you think about unit analysis. The radians have to divide out. So 180 degrees is the same as pi radians. Okay, now those pi's divide out. 180 divided by 10 is 18. Okay, 18 degrees. Sometimes you'll get a measure in radians that doesn't have pi in it. So in this case, 6 radians. Again, we want degrees in our answer. So we multiply by 180 over pi now. Same as before, but take a look. So the radians divide out. And so this, to keep it exact, we actually have to keep the pi in the denominator. What is that? 600 and 480. So 1080 over pi degrees. I'm just going to fix that degree. Okay, so that degree, that measurement in degrees actually had a pi in it. Doesn't happen that often. Depends what you're beginning. If you begin with something that doesn't have pi in it to start, then it will in the end. Okay. So complete the table. So angle in radians, angle in degrees. It says you can use decimals, nearest 10. So here we would go, okay, we've got radians, so I've got to take 5 pi over 7 multiplied by 180 over pi. So that those radians divide out and that you're left with degrees. So here, pi divides out. Now it does say nearest tenth, so you can get out your calculator if you want. And go 5 times 180 divided by 7. Okay. We're just going to do the first two, and then you can finish the rest. Then here, degrees to radians. So now I go 35 degrees times pi over 180. This says exact value. So you can have a pi in it. 5 goes into 35 7 times into 180 36 times. And you're going to redo these in your own time. And I talked about this here. You may have noticed that when the angle measurement is in radians, there are no units. By convention, an angle measurement is considered to be in radians unless otherwise indicated. So it's like your default settings, right? So for instance, an angle in 90 would be considered as radians instead of degrees because there's no units. So be careful. If it's supposed to be in degrees, you need that little symbol. So those of you that are kind of lazy with your units, you can't be lazy anymore. Okay. If you want to use units for radians, then we often use RAD, rad for radians. All right. So doing some reference angles, coterminal using radians. So draw each rotation angle for theta or beta in standard position and state its reference angle, all in radians here. Okay, so without converting to degrees, 3/8 pi. So think about, so pi is a half rotation. 90 degrees is the vertical here, which is pi over 2. Half of pi. Is 3/8 smaller than a half or bigger than a half? Smaller. 4/8 would be a half. So right away, you don't need to figure out what that angle is. You know that the terminal arm is going to be in the first quadrant. Okay? Because 3/8 is smaller than 1/2. All right, so we've labeled that. So this is 3 pi over 8. Now our reference angle, because it's in the first quadrant, is the same value. Don't need to do any work. Okay, now we're going in the negative direction. To go to that negative y-axis, that would be negative pi over 2, negative 1/2 pi. So compare 2/5 and 1/2. Is 2/5 smaller than a half or bigger than a half? Smaller, right? Really 2.5 over 5 is a half. So it's smaller, so you're not going to quite get there. That will be your terminal arm. So this will be negative 2 pi over 5, because we're just doing a sketch. We're not measuring it exactly. Now reference angle, because it's a negative angle in the fourth quadrant, it's just the positive of that. Okay, the negative tells you the direction. Okay, next one. Initial arm, 4 radians. There's no pi in it. So remember that pi radians is half a rotation, which is 3.14. This is 4, so that's bigger than 3.14, but it wouldn't be as much as going to the negative y, right? Another pi over 2. So that's going to be somewhere in here. So 4 is bigger than 3.14, but not as big as 3 pi over 2. You could find the decimal form if you want to. 3 pi divided by 2 is 4.7, yeah. So it's between. So there's your 4 radians. Now, what is your reference angle? Remember, we take that position angle 4 and subtract the half rotation that gets you to that negative x-axis, which is pi. And we can't simplify that, right? We're trying to give it, it doesn't say exact, but we want to keep it exact, 4 minus pi. If it did say to round, then you go 4 minus pi. It's 0.86. This one, negative 1.6. Okay, so we're going in the negative direction. Is negative 1.6 going to be in quadrant 4, quadrant 3? So remember, pi over 2. So that one you might want to check. We already did something similar. So check what pi over 2 is as a decimal. It's 1.57 would get you to there. We have to go a little bit further. So this is actually a little bit into quadrant 3. Okay. So that reference angle is this angle in here. That's a negative. So really, it's the same as saying pi minus 1.6. That would be the exact value. If we found the decimal of that, pi minus 1.6 is 1.54. Again, it needs to be less than 1.57 because that was the equivalent to 90 degrees. And the reference angle has to be less than 90, or pi over 2. We have all done. Okay. All right, so same kind of chart as with degrees, except now with radians. Again, try not using your calculator too much. Different standard position angles with terminal arms in different quadrants can give the same reference angle. Complete the table, stating the standard position angle between 0 and 2 pi with the terminal arm in the indicated quadrant. So pi over 4, remember, that is basically the line y equals x, that line is, that terminal arm is on. So that's in the first quadrant. Okay, so it has the same, reference angle is the same as the standard position angle. So pi over 4 as a reference angle there. What is the standard position angle? That would be a half a rotation, which is pi in radians, minus the reference angle. So let's collect like terms, because they both have pi in it. So that would be 4 pi over 4 minus 1 pi over 4 is 3 pi over 4. Okay, and you may already, once you get that unit circle, that circle with all the angles memorized, you would maybe know that already. So here, reference angle is pi over 4. Half a rotation is pi plus pi over 4. Common denominator of 4, that's going to be 5 pi over 4. 1 1/4 pi, right? Reference angle of pi over 4, so that's going to be 2 pi, complete rotation, minus the reference angle. Common denominator, that'll be 8 pi over 4 minus 1 pi over 4 is 7 pi over 4. Okay, so those are actually common ones you'll use because pi over 4 is a special angle. 3 pi over 7 is not. So these next ones won't be as common, but the same process. So in the first quadrant, remember it's going to be 3 over 7 is in the first quadrant. It has to be because it's a reference angle. We would be incorrect if we put something in here that was greater than pi over 2. So in here, this answer is just going to be the same. Okay, so reference angle of 3 pi over 7, so that's going to be the reference angle. So now our standard position angle will be pi minus 3 pi over 7. So with a common denominator, 7 pi over 7 minus 3 pi over 7 is 4 pi over 7. If you hate fractions, shouldn't really be an IB because it's going to be tough for you. There are no calculator portions of the IB exams, etc. But you could just take the part that doesn't have pi in it. So pi would be 1 pi minus 4/7, and then math frac 3/7 pi. Oh, I guess I did the other way around, sorry. So pi 1 minus 3/7. is 4/7 and put the pi in with it. Okay, so you can kind of fudge your way a little bit if you don't want to do fractions. Okay, there's your initial arm, terminal arm, and third quadrant. So we want the angle that's going to be 180 plus the reference, 180, which is pi, plus the reference. So 7 pi over 7 plus 3 pi over 7 is 10 pi over 7. And then last one. So that's going to be here. Oops. And that's going to be 2 pi minus the reference. And so 2 pi with a denominator of 7 would be 14 pi minus 3 pi is 11 pi over 7. Okay, then I'm going to leave this. You can do these because you can actually use your calculator if you want to, right, because it's decimals, or you can leave it as pi minus 1.2. Fine. Yeah, so I'm just going to leave that for you to do. Okay. And then the reference, we already did this. Only thing different is that instead of 180, it's pi, or 360, it's 2 pi. So, oops. So this is the same. Then this is pi minus the reference. This is pi plus the reference. And this is 2 pi minus the reference angle. Okay. More questions? Drawing these. So again, see if you can do them without converting to degrees. So 2 pi over 3. So is 2/3 bigger than 1/2? But it's not as big as 1. It's less than 1. So it's going to be something like that. So that's 2 pi over 3. Okay. Next one, think about 8 pi over 3. 8/3. Maybe even convert it to a mixed number. If you think about 2 pi with a denominator of 3, that's 6 pi over 3. This is 8 pi over 3. So going a complete rotation is 6 pi over 3, and we need 2 more pi over 3, which is what we just graphed. So it's going to have the same terminal arm. Negative 4 pi over 3. So negative 4/3. Negative 3/3 would get you a half a rotation. And now we're going another third of a rotation. Same terminal arm. Okay, 14 over 3. That's more than a rotation for sure, because 6 pi over 3 is the same as 2 pi. So one rotation is 6 pi. Another rotation gets you to 12 plus 2 pi over 3. Same terminal arm. When an angle is in radians, to find a coterminal angle, just add or subtract increments of 2 pi. Radian form of 360 degrees. expression. Okay, so now here write two positive and two negative coterminal angles. So I'm just going to do the first one and then you can do the second. And the, yeah, or maybe I'll do 2 out of the 4 here. So coterminal angle that's positive, so you go pi over 3 plus 2 pi. Okay, what is 2 pi with a denominator of 3? It's really the same as 6 pi over 3. So that's equal to 7 pi over 3. Right? Then if we add 6 pi over 3 again, we would get 13 pi over 3. Negative, we would subtract, so we'd have pi over 3 minus 2 pi, which again is like subtracting 6 pi over 3. So that would be negative 5 pi over 3. Okay, oh, let me change that to red. Okay, so then if we subtract another 6 pi over 3, we end up with negative 11 pi over 3. So really, just convert 2 pi to whatever the denominator is. And then you can add or subtract that. So here you could add 12 pi over 6. I'm just going to, sorry, set. Okay. Subtract 12 pi over 6 and multiples of that. Easiest way. Okay. So I'm going to leave it here. I'll just give you a hint. So we could add 2 pi would be equivalent with a denominator of 9 would be 18 pi over 9. Subtract 18 pi over 9. Now doing that in this one would still give you a positive 2 pi over 9. So we'd have to, that's not done yet, right? So we'd have to subtract another 2 pi, another 18 pi over 9 in order to finally get a negative. So again and again to get 2. All right, and that you can use your calculator, so that's pretty straightforward. So I'll leave those ones for you to finish off. And then take a look here at 14, again with radians, same question. So take a look at what those angles have to fall into. So if this has a denominator of 5, you might, to help yourself, show these with a denominator of 5. So that would be negative 20 pi over 5 and 25 pi over 5. Okay, so that might help you a little bit. So coterminal here, so if I'm adding 10 pi over 5, I'm going to get 12 pi over 5. That's still good. Add another 10 would be 22 pi over 5. That's still good. If I subtract 10 pi over 5, I will get negative 8 pi over 5. That's good. Another minus 10 would be negative 18 pi over 5. Still good. Any more than that will be beyond the boundaries. Okay, but it does make it easier if you convert this to have the same denominator. And all angles would be 2 pi over 5 plus or minus multiples of 2 pi. So 2 pi n, where n is a natural number. All right, big lesson, but done. Make sure you go back, fill in the few questions that we didn't do. And there's practice in the textbook. Make sure you do some practice. Each day, really important to make sure you've done a little practice, a little of the review at least, the assigned questions, because if you say leave a lot of work till the weekend, it's really hard to catch up on this stuff, right? Because it builds on itself so much, and you haven't, it's kind of new, right? You haven't done a lot of this before. So really important to have some practice.